So good everyone. My name is A Catalyst and I'm a medical student of the prestigious University of Ibadan. And this is what I do. I post lectures videos and I also share tips about Jambs, how to pass your exam and how to excel in your Jamb. So if you are seeing me for the first time, I've made video on scalars and factors. I broke down the concepts you need to understand on factors and scalars. Please, if you haven't watched that video, please go and watch it now and subscribe to my channel, please, because you need to understand concepts, you need to understand topics before you move to solving past questions. So now today I'm going to be solving past questions on scalars and factor, and please pay attention to this video. Please make sure you like this video and share it, because as you are sharing it, you are helping me to reach a larger number of students that need this video. So now let's move on. So I will be dictating those questions and they will be appearing on your screen. Don't worry. So the first question I have here is: a man walks 1 kilometer due east and then 1 kilometer due north. His displacement is what? Look at this very carefully. A man walks. So now, just this very carefully. A man walks 1 kilometer due east. This is east, right? This is north. And this is what? This is west and this is south. So a man walk 1 kilometer due east. This is east, right? So 1 kilometer. And then 1 kilometer due north again. From here, 1 kilometer due north. His displacement is what? So I told you that the last video I differentiated the differences between scalars and factors, that distance is a scalar quantity while displacement is a factor quantity. Please, I'm saying it again. If you haven't watched that lectures, please go and watch it now before you start watching this one. Are you getting my point now? So in this case, we are told to calculate the displacement of that man. Now, this is the first this is the starting point and this is the destination. So the first locomotion is eastward. Then from eastward, the man it goes upward, which is northward. Now we have to calculate the displacement. I told you that displacement is a vector quantity and it is the shortest distance from the starting point to the destination. It is the shortest straight line from the starting point to the destination. Now, this man distance will be equal to 2 kilometers. Yes, it will be equal to 2 kilometers because distance is scalar quantity and the how to calculate scalars is just the algebraic sum. So just 1 plus 1 will be the distance. But in case of displacement, it is different. Now, this displacement will be this line. So the displacement, what Dwayne is saying is that instead of you to be going like this and going like this, why can't you move straight? This is your destination and this is your starting point. Instead of you to be going this way, why can't you move straight from this place and end here? So the displacement will be the length of this line, this hypotenuse. So now I'm going to use Pythagoras theorem to solve these questions. You know, this is the hypotenuse and this is the adjacent or the opposite. So now this resultant or displacement, let me just write displacement. So this displacement will now be this square equal to 1 square plus what? Plus another 1 square. That will be equal to what? 1 plus 1. This square will be equal to what? 2. Take the square of this displacement. That will be square root of 2 kilometer. 2 what? 2 kilometer. That will be for the what? The value of our displacement. Is that clear? That will be the value of our displacement. The shortest distance from the start. In fact, this is very simple. The shortest distance from the. Let me just give you another bonus. Let me just give you another. If a man moves from A to B, if a man moves from A to B, and the distance is 10 kilometer and move backward, and the man move backward 5 kilometer and stop here. See, if you are asked to calculate the distance of this man, the distance will just be the algebraic sum, which is the scalar quantity, which will be 10 plus 5. Distance now, sorry, distance will what? Will be 10 plus 5, which will be 15 kilometer. But for displacement, please calculate it like that. Displacement will be the shortest distance from the starting point to the destination. So this man started from here and the destination is this place. So you are only going to calculate the length between these 2 points. The length between these 2 points, which is what? Which is 5. That will now be 5 kilometer eastward. 5 kilometer. That's very simple. Because the displacement is telling you that, okay, since this is your destination and this is your starting point, why can't you just move straight like this for 5 kilometer? Why do you have to be going 10 kilometer and then coming back again? That's a wasting of time. That is for displacement. So the question 2 now. Now for the question 2. An aircraft attempts to fly due north at 100 km per hour. If the wind blows against it from east to west at 60 km per hour, its resultant velocity is what? Now, this problem of vector is very, very simple. Just pay attention to it very carefully. It's something that is applicable. That is practicable, something you do at home. Now, an aircraft attempts to fly due north at 100 kilometers. Now, this is the initial velocity or the initial direction of the aircraft. They said due north, 100 kilometer. 100 kilometer due north. Let me just write it very well. Per hour due north. And then the wind blows against it from east to west. So that means the east is blowing this direction from east to west. From east to west. This is the direction of the wind, right? And the speed of that wind is 60 kilometer. 60 kilometer per hour. So its resultant velocity, I've told you the meaning of resultant. If you go and watch the first video, that resultant means the final result. If two vectors or one vector is acting or are acting at a point, then the resultant of the point they are acting is the resultant. Then what they are saying is that what happened afterward, after that actions, what happened afterward. So what they are saying now is that this is the direction of that aircraft, and this is the direction of the wind. So now, what is now going to be the direction? We all know that this is the direction of the wind. Definitely, it will deviate the direction of this aircraft. It will deviate it. It will lean towards this side. What I'm saying is that this is the initial direction of the aircraft, but this is the direction of the wind. That means that this wind will eventually bend the direction of this aircraft. It will bend it. So that this bending line will be the resultant. What happened after the reactions? Are you getting me now? Will be the resultant. If the wind blows against, so its resultant velocity now, that means that we're going to calculate the velocity of this what? Of this aircraft. Let me just draw it very well so that. So I'm not going to draw something like this. I'm going to draw something like this. So this line will be equal to this line. This line will be equal to this line. So that means that the speed here will be equal to the speed here, which is 100 kilometer per hour. Are we together now? And the wind speed is what? Is 60 kilometer per hour. 60. So now I'm going to calculate this hypotenuse, which will be the resultant. So I'm going to use what? Pythagoras theorem again. So you must understand some mathematics to be able to solve some physics. Our resultant now, r squared will now be what? will now be 100 square plus 60 square, which is equal to what? 10,000 plus 3,600, which will equal to what? 13,600. Am I right? So R now will now be what? The square root of 13,600. So what is the square root of 13,600? That will be what? That will be 117 kilometer per hour. So that will be the what? That will be the resultant. That will be the resultant. So we can still calculate the directions. You know, vectors has both magnitude and directions. Now, what is here is direction. I mean the magnitude. So we also need to calculate the direction, especially if you are writing WAEC and all those NECO. You need to know how to calculate because they will ask you to. Are you getting me now? But for Jamb students, so Jamb students too, you need to learn it too. They used to ask as well. So now, this is the direction. I'm going to calculate this angle. I'm going to calculate this angle because this will be the direction. Are you getting me now? This will be the direction. So now we are going to calculate this angle, and then we are going to remove this angle from 90 to get this angle that is here, because this angle will be the direction. I'm sorry, this angle here will be the direction. In my last video, I have explained the reason why you must use the angle that is here. You don't use the angle that is here. You use the angle inclined to the north or the angle inclined to the south. Yes, I've made video on that. Please go and watch it. So after we are getting this angle, you can now use this angle to get this angle by removing this angle from 90, because this angle here is 90. Are you getting me now? So how to get this angle now? We can get this angle by what? Using SOHCAHTOA. Are you getting me now? So we can use tan. We can use tan theta, which is what? Opposite of adjacent. 100 all over adjacent, which is what? 0 cancel 0. That will be what? That will be 5 all over 2. What 5 over 2? That will be what? 2.5. So whatever this thing be, actually I'm not with calculator now. Yes, I'm not with calculator. My calculator has spoiled. So whatever this thing be, you remove that value from 90. So whatever that be will be the what? Will be the directions of that resultant. Are you getting me now? Question 3. What is the magnitude of the resultant two forces 20 Newton and 15 Newton? Okay, what is the magnitude of the resultant two forces 20 Newton and 15 Newton inclined at 90 degrees to each other? Now, this one now, we are asked to calculate the resultant of two vectors acting at 90 degrees to each other. Of course, that's very simple, you know. So this one now, 90 degrees to each other, the direction of this one, and this is the direction of this one now. So we all know that I have thought about this one, that whenever two forces are acting at a point, so the resultant means the final result, the final direction, the magnitude of the point they are acting to. Now this body that is here will eventually move here. It will move here. This will be the direction of the resultant. So, and the first force is what? The first force is 20 Newton and the second one is 15 Newton. It's 15 Newton. Now, calculate the resultant. We are going to change this one to what? To triangle. Please go and watch. That's why I said you go and watch the first video. I don't want to be explaining so that I will not be wasting too much of our time here. So This side will be equal to this side. That will be 20 Newton. We're going to use Pythagoras theorem again to get the answer, which is r square. See what is happening to you now. R square is equal to what? 20 square plus 15 square. So r square now, 20 times 20, that will be 400. 15 times 15, that will be 225. Am I right? Yeah, that's 225. So r square 400 plus 225, that will be what? That will be 625. Then take the square of the r, that will be square root of 625. That will be what? That will be 25 Newton. 25 Newton. 25 Newton. So that will be the what? The resultant magnitude. We haven't calculated the direction now. So this angle will be the direction. This angle will be the direction. This angle will be direction. So we're going to calculate this one. We're going to calculate this angle and remove 90 from it to get this angle. So that will be our direction. That will be our direction. How can we do that? So the way I did the first one, do it like that. Tan theta. Tan theta will now be what? Will now be opposite. All over adjacent 15. That will be what? That will be 4 all over what? All over 3. Tan theta will now be what? Will now be 4 divided by 3. So I'll know with calculator. So 4 divided by 3 will be what? Maybe 1.33. So you find the inverse of tan. So whatever this thing be in your calculator, you remove that number from 90 to get the direction of this resultant. That's all. So two forces P and Q acting perpendicularly to each other have resultant of 50 Newton. If P makes an angle of 30 degrees with the resultant, calculate the magnitude of Q. This is the two forces that are perpendicular to each other, meaning that they are at angle 90 degrees to each other. This is P and this is what? This is Q. Now, the magnitude of the resultant is 50 Newton. 50 Newton. So 50 Newton, and this is the resultant. So now, we are now asked to calculate the magnitude of Q. Please go on. I'm saying it again. Go and watch the last video I did on this thing. In this case, now we are going to resolute this resultant. We're going to resolute this resultant. Resolution of vectors. So we're going to resolute this one to get the value of Q. And they say that the angle inclined, if P makes an angle of 30 degrees with the resultant, this P and resultant makes an angle of 30 degrees. So now we are going to resolute this force, this resultant, to get the value of Q. And I have told you, I've did video on that we are going to, now that will now be resultant. I mean, this Q will now be what? Resultant sine 30. I've made video on why it is sine 30 and why it should be cos 60 or r cos 60, because the angle here is 60. I told you that always use cos theta of the component you are trying to calculate. Always use cos theta of the angle of the component you are trying to calculate. If I want to calculate this vertical, I mean this horizontal component, I'm going to use cos theta of this angle. If I want to calculate the effect vertical component, I'm going to use cos theta of this angle, the angle inclined to the component I'm trying to calculate. So if you now want to use sine like the first one now, you're going to use this angle of the second side, not this one again. I hope you are getting me now, please. So r, which is 50, times sine 30 will be what? It will be 0.5. So that will not be what? That will be 25 Newton. That will be the what? That will be the magnitude of Q. Hope you are getting my point now. Question 5. Question 5. Question 5. A block of mass 2 kg resting on a smooth horizontal plane is acted upon simultaneously by two forces, 10 due north and 10 due east. The magnitude of the acceleration produced by the force of the block is what? A block of mass 2 kg. This is a block of mass 2 kg on the floor now. It's being acted upon by two forces. One is due north. One is due north, and the force is 10 Newton, and another is also 10 Newton, the due east. Due east. 10 Newton. Due east. So now, we are now asked to calculate the acceleration of this body. Like I said earlier, the last video, that if your brother stand there and you stand there and you tie the rope, both of you tie the rope to a box here, and you try to pull it northward, and your brother to try to pull it eastward, this body will move in between two of you. It can't go here and can't go here. It will move in between two of you. So the same thing with this box. These directions will be the what? The resultant. So after we have not gotten the resultant now, which is the force. Force is equal to mass times acceleration, and we have gotten the mass here. So we're going to what? We're going to make just let us find this thing first. The resultant. So resultant now, how we used to do it? Now. This one will be the what? This one will be 10. The size of this one. So we're going to use Pythagoras theorem again. Which is what? R square 10 square plus 10 square, which is what? R square is equal to what? 100 plus 100. R square is equal to what? 200. And then R now will now be what? The square root of 200. R now will now be what? Will now be what? What is the square root of 200? 10 root 2. Root 2. 10 root 2. So that would be what? The value of the resultant. The value of resultant. Are you getting my hand now? So we are not getting the force. We have not gotten the force. How fast this thing will move. Or are you getting me now? So now we are not going to calculate the acceleration. Now I told you that R is equal to F. So F, which is the force, is equal to what? Mass times acceleration. So acceleration, you got F over M. What is the F? This one. 10 root 2 all over what? All over M, which is the 2. The mass of that body. 2 cancel, then that will be what? 5. That will be what? 5 root 2. So now question 6. Question 6. Two forces act on the body. The one of magnitude 5 Newton acts due east. The other of magnitude 3 Newton acts in the direction of 30 degrees. Calculate the resultant vector and the direction. You see, this question is different from the one we have been doing, because the angle between this one is less than, let me just solve it on the board so you can see. Two forces. The first force, which is acting on the body, is due east. That means that body is pushing, it is pulling that body. This is the body now, and the force is pulling it towards east. And the magnitude of that force is 5 Newton now. The other force again acting on that point again is of magnitude 3 Newton in the direction of 30 degrees. So in this case, what I'm saying is that the second force, you know, this is north, right? This is north. So what I'm saying now is that the second force is at angle 30 degree to the north, to the north. So that will be 30 degree what? To the north. So you can now see that what is the angle of this angle? What is the angle between this place? That will now be what? That will now be 90 minus 30. That will now be 60. That will now be 60 because the angles um anything like this, right angle to angle, that is 90. So that will now be 90 minus 30. That will now be 60. So now in this case now we are going to remove these two factor, these two factor, these two factor. Are you getting me now? These two factor. So the angle between them is 60 degree. So what is the resultant? I told you that the resultant is going to be the line between them. The line between them. So in this case, we are going to use the law of parallelogram to find the resultant, unlike the one with 90 degree. The forces in which the angle between them is 90 degrees, you are going to use Pythagoras theorems to find the resultant. But in case of the one in which the angle between them is less than 90 degree or greater than 90 degree, we are going to use the law of parallelogram to find what? To find the resultant. Let me clean this one. So now I'm going to form this thing now with parallelogram. So I'm just going to draw a dotted line, and this one will meet that dotted line. So this one now I will now draw it. Then this line will be our resultant. Are we together now? So I made two calculations, two formula during my previous video, that we are going to be using cos rule here to find the resultant. That will now be resultant square is equal to what? A square plus B square minus 2AB cos theta. Are we together now? Let me just say something first. Okay, let me just do the second formula. R square will be A square plus B square plus 2AB cos theta. You can see now the difference between these two formula is just the sign. This one is negative and this one is positive, and I will tell you how to apply it. Look at this now. Let me just label the angle that are here. The angle here is 60 degree. The laws of parallelograms, the opposite side of parallelogram, they are equal. The opposite side of parallelogram are equal, and the opposite angles of parallelogram are equal, which means that this angle is equal to this angle. This angle too will be 60 degree. So now, since we have gotten these two angles, and these two angles are the same, this one is x, this one too will be x. That will be 2x plus 60 plus 60, 120 equal to 360, because the sum of all angles in a quadrilateral, and quadrilateral means shapes with 4 angles or shapes with 4 sides. So that means that the sum of angle in this parallelogram will be 360. So with your wisdom, you should know that this angle will now be what? 120 degree, and this one too will be 120 degree, because x plus 60 plus 60 equal to 360. That will be 2x plus 120 equal to 360. That will be 2x equal to 360 minus 120. Rough calculation. That will now be what? That will now be what? 240. X now is what? 240 all over 2, 120. So I just I did rough calculation so that I won't waste much time. So now, if you want to use this angle, listen very carefully now. You see, the original angles between the two factors is 60 degree. But if you now want to use this angle to calculate your own resultant, you are going to use this first formula, minus 2AB cos theta. But if you want to use the direct angle that is in between this true factor, which is 60, the angle that was given to you in the question, if you want to use it, we are going to use this second formula. Hope you are getting me now. So in this case, let me just choose the second formula. You can use it. You can use any one. You are still going to arrive at the same answer. So now, this one is what? Is 5 Newton, don't forget. And this one is 3 Newton now. So R square will now be what? A square, 25. So we are not in primary 2. So this one, which is the B, 3 square, which is what? Is 9. Plus 2AB, 5 times 3, which is what? 15. Cos what? That will be what? Cos 60. Cos 60, thank you. R square now will now be what? 25 plus 9. That's what? That's 34. Is that 34? Yes. Plus what? Plus 30 times cos 60 is 0.5. That will now be what? 34, 30 times 7.5, that's 15 plus 15. So 34 plus 15, that will be what? That will be 49. 49. So to take the square of this R, that will be R square root 49, which will be what? 7 what? Is it in meter? Yes. I mean, is it in Newton? 7 Newton. Now we are told to calculate the direction as well. The direction as well. Please, I want you to listen very carefully now. I told you to calculate the direction. So we have gotten the magnitude, but we also need to calculate the direction of that resultant. So this angle will be the what? This angle, I mean, let me just think that as a distance. So this angle will be the what? Will be the direction between, the direction of the resultant now. So we're not going to draw it out. We're going to draw this thing out. Are you getting me now? 20 degree and what? Theta. This side will be what? 3 Newton. Don't forget, the side of parallelogram, they are equal. This one will be equal to this side, 3 Newton, and this one too is what? This one is what? 5 Newton. Are we together now? 5 Newton. And this side will be what? We have gotten our resultant, 7 Newton. So we are going to be using sine rule. We're going to be using sine rule to find this formula. So we state that this angle, I mean, this angle all over we're going to be using this this sine rule to find the answer now, which state that, you know, this is the side and this is the angle facing this side. This is the side and the angle facing this side is this one. I get my now. So we're going to use this angle to find it. That will now be what? That will be 7 all over sine 120 is equal to what? Is equal to 3 all over sine this angle. I get it now. So we're going to make this one the subject of formula. Okay, let me just 7 all over what is happening now. What is sine 120? 180 minus 120, that will be 60. So sine 120 will be what? Will be 0.886. 0.886 equal to what? 3 sine theta. So sine theta will now be what? Will now be cross multiplication. Please, we are a physics student, so I expect you to have no mathematics. So we are going to cross multiply. That will now be what? That will now be 3 times 0.886 866 all over what? All over 7. Whatever this thing be, we're going to find the inverse of sine to get the what? The value of that angle. The value of that angle. Are we together now? So that's it.